Complex fractions. A complex fraction is basically a fraction within a fraction. So I always point out the importance of identifying the problem before we jump into doing anything. These should be pretty easy to identify, as you can see in the example here. Overall, we have one fraction, and then we have fractions within the numerator and or denominator. The problem with complex fractions is that they're not considered simplified. So the steps to simplify a complex fraction, or reduce it down to just one, is to begin by finding the LCD for every fraction within the numerator and denominator, which we do know how to find the LCD by now. Then what we're going to do is multiply the entire numerator and the entire denominator by the LCD. Simplifying will then reduce it down to just one rational. So example 1, complex fraction. Overall, this is just one fraction, as we see in the division symbol here, but within the numerator we have two terms, one of them being a fraction. Within the denominator we have two terms, one of them being a fraction. So we want to begin by finding the LCD for the two denominators, one in the numerator, one in the denominator. Well, in this case they both have the same denominator, x, so the LCD is simply x. Once again, what we're going to do with it now is multiply the entire numerator by x, the entire denominator by x. So distribute that x in the numerator, it gives us 10x plus x times 8 over x. The x's cancel out, leaving us just 8. So we got rid of that fraction in the numerator. The denominator, do the same thing, distribute that x times 25, 25x, x times 20 over x. The x's cancel out, leaving us 20. So we no longer have a complex fraction, but we still have a fraction, so we always need to make sure it's simplified or reduced. So the numerator we can factor out of 4, or excuse me, factor out of 2, we're left with 5x plus 4. The denominator, factor out of 5, we're left with 5x plus 4. So obviously the 5x plus 4's cancel out, so that entire problem reduces or simplifies to just 5, or excuse me, reduces to 2/5. Example 2. Another complex fraction. In this case, we have two terms in the numerator, one of them being a fraction. But we have three terms in the denominator, two of them being a fraction. So the LCD, look at all three of those denominators, x, and x squared. Well, they all have obviously a base of x, but we have to include the largest exponent of the factor x, which of course in this case is x squared. So the LCD, x squared, multiply the numerator by x squared, multiply the denominator by x squared. The numerator, distribute x squared times 3, 3x squared. X squared times negative 18 over x, one x in the denominator cancels out with one of those x's in the LCD, leaving us just negative 18x. The denominator, x squared times 1 over x, once again that 1x in the denominator cancels out with one of those x's in the LCD, leaving us just x. Minus 42 over x squared here, both x's, the x squared cancel out, leaving us just negative 42, plus x squared times 1, nothing cancels out, so x squared. So at this point, we no longer have a complex fraction, but we still need to simplify. It may help us to put that denominator in standard form, or we need to in order to factor it. So the numerator, factor out a 3x, we're left with 3x times x minus 6. The denominator factors into x minus 6 times x plus 7. So the x minus 6's cancel out, leaving us 3x over x plus 7. Example 3. A lot going on in this problem, but it's actually a pretty simple problem. One we've already done. One fraction overall. And within the numerator, we only have one term, but it's one large fraction once again. The denominator is all one term since it's all in one fraction. And keeping in mind that a division, or a fraction, is nothing more than a division problem, basically, we could rewrite this problem as the numerator simply divided by the denominator. Since there's only one fraction in the numerator and one fraction in the denominator, all one term, this is basically nothing more than a dividing two rationals problem. So we know when we're asked to divide two rationals, we change it to multiplication by taking the reciprocal of the rational that immediately follows it. And in the process of doing that, we can go ahead and factor. That first numerator factors into x plus 8 times x plus 11, its denominator, x minus 5 times x plus 1. The second rational, the denominator becomes a numerator, so it factors into x plus 6, x minus 5. The numerator became the denominator, factors into x minus 11 times x plus 6. So cancel. The x plus 6 is in the second fraction, reduce or cancel. We can cross cancel. The x minus 5's cancel, leaving us x plus 8, x plus 11 in the numerator, all over x plus 1, x minus 11 in the denominator. And number 4, another complex fraction. In this case, there are two terms in the numerator, so we can't use that same trick or technique we just did in the earlier problem. We have to find the LCD. So all three terms, 2 in the numerator, 1 in the denominator, all the denominators are already factored. So the LCD, x plus 4 times x minus 6. So we're going to multiply the numerator by x plus 4, x minus 6, and multiply the denominator by it as well. In the numerator, the x plus 4's cancel out, leaving us 10 times x minus 6, minus x minus 6's cancel out in the next term, leaving us 6 times x plus 4 when we distribute that LCD. In the denominator, just the x minus 6's cancel out, so we're left with the numerator, 3x minus 63, times that remaining factor in the LCD, x plus 4. So we no longer have a complex fraction. Certainly need to do some simplifying. The numerator, distribute that 10x minus 60, minus, distribute the negative 6, 6x minus 24. The denominator is almost factored. We don't certainly need to FOIL it together, but what we should notice is that first factor is not completely factored. There's a common factor of 3, so we need to factor it out of that first factor, leaving us x minus 21, and that remaining factor, x plus 4. Continue on simplifying the numerator, combine like terms. 10x minus 6x leaves us 4x minus 84, all over that same denominator. Now we just need to factor the numerator. Factor out that 4. When we do that, we see the x minus 21's cancel out, leaving us just 4 over 3 times x minus 4. Excuse me, that should be x plus 4.